All right, so 10.2, developing formulas for circles and regular polygons. Okay, so the circle, you're kind of used to, you've done this before. One thing that's of interest here is the top of page 688, it gives you the symbol for a circle. So there's actually a symbol for a circle, and it's this. That notates a circle. So if you go like that, it'll be circle A. Circle A. Okay? All right. So if I have a circle with a radius of R, the radius is R, and we're talking about the circumference. What's the circumference? The circumference is equal to 2 pi R. Okay. Area is equal to what? Pi R squared. And it would tell you what the diameter is. Diameter is nothing more than 2 times the radius, right? Because the diameter is from here to here, correct? You're just stacking 2 radiuses here, right? Example number A. Number 1. Number 1. Find each measurement where they're giving you the 16 there. What is the 16? Which one is this? Is this the radius? Huh? It's a diameter, right? This is the diameter. So therefore, the radius must be half of that. Therefore, the circumference, hold it.
So it'd be 8 pi. So it'd be
2 times pi times 16 pi, right? So 2 pi, 8, 16 pi. Okay. If nothing is, no word has been given, pi is going to be equal to what? 3.14, right? You just do it out, right? Okay. In my classes, normally I allow you to leave it like that. I don't know what the assessments that we're using are going to be able to do that. But if you left it like this on a, it's not a multiple choice, and you just left it at that, you would get full credit from me. Okay. What is the area? Area is going to be equal to pi r squared, pi, so it'd be 8 squared, 64 pi. Right? Okay, so that's that. B, find the radius of circle X when the circumference is 24 pi. So the circumference here, they're telling you is 24 pi, okay, which means that R had to be what? Had to be 12, right? 2 times 12 is 24, and the pi, 24 pi, so the radius must have been 12. C, circumference of circle S, in which the area is 9x squared pi. So the area is equal to 9x squared pi. And what I'm trying to find here is the radius, right? I need to find the radius in order to find the circumference. And divide both sides by pi. Pi's cancel out. Trying to find the radius. So the radius is going to be square root of that. And that's going to be equal to 3x. Right? 3x squared is 9x. 3x squared is 9x squared. Right? So since this is the radius, and they actually wanted to know what the circumference was, the circumference is 2 pi r, which in this case is this, 6x pi, would be your answer. Let's do example number 2. Number 2, you have a drum kit. 3 drums, diameters of 10, 12, and 14 inches. Find the area of the top of each drum. Area, so the area is going to be equal to pi r squared, where r, the first one, we have 3 different drums. So what is the radius of the first one? 5. Next one would be 6 and then 7, right? 10, 12, and 14. So therefore, the area of this guy is going to be pi r squared. This guy's going to be pi r squared. This guy's going to be pi r squared. It actually tells you on this one, though, to use the 3.14 and round to the nearest 10. Then you would have to actually plug in the 3.14 and do the arithmetic. Okay, so let's move on to something more interesting, because the circles are actually, this is all review, right? You guys have done this before? Right, you guys have done this before, right? Okay, so let's go ahead and do the area of a polygon. And when we do the area of a polygon, we get to introduce a new term. This is a circle, so this is or my best try of a pentagon here. Okay. Now, in order to find the area of a pentagon, you're going to have 5 equal triangles here, right? Can you see that each one of these triangles are an isosceles triangle? Because these are all radiuses, right? They're all the same. Right? It's a regular polygon. This guy here, this height of one of these triangles is called the apothem. Apothem. Well, these sides we call a side. Okay, all right. So the area of a regular polygon, is 1/2 the apothem, apothem times the perimeter. Perimeter here is how many sides do we have? On this one, we have 5, right? It's the pentagon, so it'll be 5s on this one. Okay. So if you go on the very bottom of page 689, it gives you that equation where the area is equal to 1/2 times the apothem times the perimeter. That's the page, go to example number 3. So we're going to do a couple of examples here. A regular hexagon with side length 6. The perimeter is, so trying to find the area of this polygon. Area of this polygon, so it's 6-sided, which means that this angle would be what? Anybody tell me? How many triangles am I going to have in a hexagon? You're going to have 6 of them, right? Because I have 6 sides, right? I have 6 sides of the hexagon, right? So since I'm going to have 6 equal angles here, can you see that this is 60 degrees because it's 360 divided by 6? Right? Okay. an isosceles triangle, which means that these two have to add to 120, which means that this guy is a 60, this guy is a 60. So it actually is a equilateral triangle. And this is important because that is how you're going to find out what the apothem is, right? As we were told, one side was 6, right? So from here to here is going to be what? 3. Here to here is going to be 6. That's the equilateral triangle. I need to find the apothem A. 6 squared is equal to A squared plus 3 squared. Can you see that? In this triangle right here. So what do I have? I have 36, A squared, 9. A squared is going to be equal to 27. That's your apothem, right? So if their apothem is square root of 27. Your perimeter is what? I have this from here to here is 3, here to here is 6, and I have how many of these? 6. So your perimeter is going to be 36. You see that 6 times 6 there, right? So, eighteen times 3 is 54 all day. That's your answer. B, again, in my class, you can leave it like this. You don't need to go any further. If they want you to go further and do the, so many decimal points, then you'd have to go. And remember that this, you'll put that guy, multiply that guy. Okay. Example number B, a regular pentagon with a side length 8. So a pentagon with a side length 8. A little different. So that's actually thought, well, my sketch there is so bad, I'll try to redraw it, okay? So I have example 3, continuation B. I have a pentagon, which means that this angle is what? What is that angle? Just as we did the hexagon, remember we divided 360 by the number of sides? So now we're going to divide 360 by what? How many sides? We have 5, right? So we divide it by 5, you're going to get 72 degrees. And again, you're trying to find the apothem, right? But you know that this length is half of the side, and you're given the side as 8. So this is 4. You're trying to find A. So this is where it gets a little dicey. 36, 4, you're trying to find A. Right? Tangent of 36 is the opposite over the adjacent. Trying to find A. I'm still trying to find the length of A because I know what the perimeter is. The perimeter is what? I have 8 times what? How many sides? 5, right? So this is going to be 40. I know this is 40 already. I just need to find A. Okay. So here we're going to do the trick where we flip both sides. 1 over tangent 36 degrees is equal to A over 4. Then I'm simply going to multiply 4 on each side. This 4 cancels out. That's my A. Right? According to the book, that would be, I don't know what it is. Okay. So it's gonna be 1/2 this guy times P. We found that P to be 40. Right? To 80 divided by tangent 36. According to the book, that is 110.1. Or approximately that, obviously, right? Any questions? You good? All right. 10.2, your homework for 10.2. Two through 30, okay. Careful here. Even only. Okay. Don't go doing all 29.